Okay, let's see. Hopefully this will help you out. Here we go. So, on this problem 7, they're asking about the parent function. The parent function in this case is f of x equal to x cubed. And the thing I want to make sure you understand is that x cubed always looks like this. Okay? Now, a negative x cubed will just go in the opposite direction like this. So you ought to be aware of that, and hopefully you understand and you can memorize that fact because it will help you. So now what? Well, when we graph this, we should, again, it should be an x cubed because that is our parent function, right? So notice that we have a minus 2 here at the end. What does that mean? Instead of being in the center here, it's going to be down 2. So one of our transformations is we're going to go down 2. I don't know how your teacher shows that, but I'm just explaining it that way. So hopefully you can translate my information into what your teacher wants. So that negative 2 means it's going to go down 2. Now, see that plus 1 there with x. You have to think backwards when you're dealing with the parentheses and the number with x. A plus 1 actually means left 1. Normally plus for x means right, but you have to remember with x it's a little backwards. So what I'm going to do here is notice instead of being in the middle at 0, 0, I'm going to go down 2 and I'm going to go left 1. Now that right there, that point right there is the middle or the inflection point as we call it of this function. And this function now is going to sprout up like this and sprout down like that. And there's the x cubed like I was talking about in purple here. Okay, so please make sure you understand x cubes based on this problem. Now, just to verify real quick, remember you can make a little table as I taught you and plug in numbers. For example, if I plug in 1, I get 1 plus 1, 2 cubed, 8 minus 2 is 6. So I know if I go to 1, 6 right here is a point. And if I likewise go to negative 3, it should be negative 6 right there. So let me get my rough sketch drawn in a little bit better. So it's going to go up like that and go down like that. Okay, but anyways, you can always plug in points, okay, to help you. Actually, that should be negative 8. So instead of, that was wrong right there. It should be 2 more spaces down right there. Again, if you plug in negative 3, you'll get negative 3, or sorry, negative 2 cubed is negative 10. So it's going to be a little bit further down there. But anyways, hopefully you get the right idea here. Okay, hopefully that helps. Now let's look at number 8 here. It's just show algebraically whether or not the function's either odd or neither. So basically, it's either even, odd, or neither. So test for even, test for odd, and if neither one is satisfied, then it's neither. So what do we do is you already started out correctly right here. You plug in negative x. So I'm actually going to do f of negative x here. I'm literally going to, for this x, I'm going to use a parentheses and I'm going to plug in negative x for that x. Now, notice what happens here. I have the square root and negative x squared because even a negative squared will always become positive, right? So notice I'm back to my original function. So in other words, if f of negative x is the same as f of x, that's called the even function, I believe. And if we would have plugged in negative x and instead got a negative version, in other words, whenever I plug it in and I get the negative of the original f, then this is what makes it odd. Okay, and I wish you had more than one example to go by so I could show it to you better. But that's the general rule. And if neither one works out, then it's neither. Okay, now this one's important because, again, you should know this. So here we go. what is the range of g of x? Now remember, range is your y values, domain is your x values. So they want the range of y. Y is the blue one here. So notice, if we're talking about y, see how it's going up to positive infinity there and positive infinity this way. But the lowest it goes is -2, right? So therefore, we would say our range, remember, our y's, oh, we have to put a square bracket because we want to include -2, you see. But it goes up to positive infinity. With infinity, always use a parentheses, right? Because it's an open-ended part of the interval. Now, let's talk about domain, which is your x values. So now we're looking at the yellow one here. And if we want to know the x values, notice for y, it's going down to -infinity. It's leveling off there. So just for clarity's sake, if they asked for the range of f, we would have said parentheses -infinity up to, what's that value right there? Looks like the highest it goes is 6. So now that's the range. You just think about what the y can do. Now for the domain, you think about what the x can do, which is left and right. So notice as it goes down to -infinity for y, it's also going infinity to the left. Over here, it's also going infinity to the right. So we would say for x, because there's no asymptotes or anything to worry about, right? The x values for f of x, you see, are from -infinity up to positive infinity. Okay? Now, how about y? Yeah, I think the blue y value is all x's as well. But anyways, hopefully you get the idea. X is domain, range is y. Now, where is the interval when f of x is constant? Now, constant means it's flat, okay? No slope. If it's going up or going down, you see, it has a positive or negative slope. That means it has a constant change, right? So, try not to confuse you. We literally want to know when it's constant, and that's the yellow f of x. So notice here, it's constantly changing. It has a positive slope. In here, it's looping, right? So here it's going down, here it's going up. It levels off momentarily at the vertex, but where is it actually constant is right up here. So right up here from, what is that, 3? And that arrow means it goes on forever. So where is f of x constant? We would say from 3 to infinity. And it does include, see, there's a point there at 3. So from 3 to positive infinity, it is constant. Where is g of x decreasing? Decreasing means it's going down. So let's clean this up here. Now let's, starting over here, we want g of x, which is blue. The blue one. Where is it decreasing? So it's going down at this point right here up to, what is that, -2 for x? Notice it's going up to infinity, but from left to right it's going down. So we would say from -infinity up to -2, it's definitely decreasing. Notice in the middle here, it's just leveling off. So that's where it would be constant. From -2 to 3, we would say that one's constant. And then here, we know from +3 and on to infinity, it's increasing. So hopefully you understand all of that. Next question. The values of x such that g of x, now greater than 0 means where it's positive. So all you have to do is look above the x-axis. So g of x is a blue one again. So where is it positive is from here all the way to there. What is that, -3? And also from here all the way to the right to infinity. So that value is what? 5, right? So the answer for this one will be from negative infinity up to -3. Let me make sure. Okay, it's always positive there. Actually, we want to use a parentheses because -3 is actually has a value of 0. And then she'll probably want you to do a union here, or he will. And then from 5 here, or at least above 5, when x is 5 or more, it's above the x. From -3, by the way, up to 5, we would say from here to here, you see, the blue function, that's where we would say it's less than 0 or negative. Okay, so finishing up, we would say 5 to positive infinity. The values were f of x equals g of x. And that one's easy because all you have to do is look where they intersect. So they intersect right here. And that's at -4, 3. And they intersect here at -1, -2. They intersect here at 1, 2, -2, sorry. Watch your signs, by the way. And that's it. So they intersect at 3 points, correct? Now, technically, you can see they're going to intersect way out there, but your teacher's not going to want you to look for that one. We know on our graph shown there's 3 points of intersection, right? Where the yellow and blue meet each other. So that's what you're going to put right there. All right. On what intervals is f of x greater? So literally, you're going to look where the f of x is above g of x. So, oops, wrong way. Let's clear up the ink and start over here again. Okay, so where is f of x, the yellow, above g of x? We would say starting here, where they intersect, it's always here above the blue, always here above the blue until the next intersection here. And then it's below here. So that right there, where I just circled, is where we would say the blue is above the yellow. And it starts all over right here at this intersection point, and everywhere else, of course, until they meet over here. And that's the only problem I don't like about this function, because technically they're going to meet somewhere, but I guess you're supposed to ignore that. So we know from here to here it's above. So we're going to go from -4 to here is -1. Hopefully I'm not getting too messy. So we would say from -4 to -1, union, and then, oops, I went the wrong way again. And then we would say here at 1 to infinity, I guess. Although technically this part is wrong because they will intersect, as you can see, somewhere off the grid. Now, the last one I think is the coolest one, because all we need to do is find f of 0 and g of 3. So let me clean this up one more time. So where is f of 0? F is the yellow. F of 0 is right there, right? F of 0 has a value of -3. And the next question, or next part, says g of 3. So g is the blue one. G of 3 is right there at -2, right? So now we're ready. So basically all we have to do here, I'll do it in red here, is we have 2 times 3 times, what was it, -3, plus 4 times -2, close bracket. Let's see here. 3 times -3 is -9. 4 times the -2 is -8. If we add that together, that's -17. Times the 2 is -34. So hopefully I did that right. I didn't make any silly mistakes. I know the process was right. I'm just wondering if I just made a mistake. So hopefully this helps. So let me go back here in case you're still looking. But hopefully this video helps you, and I'll see you around.